So here's our lab room if you're sitting at the back looking towards the front. So there's the chalkboard and there's the technician's office. If you need an oscilloscope, where do you find them? Well, if you look right up this front corner here, right beside the overhead projector screen, there's a little bookcase, and that's where all of the oscilloscopes are sitting. So if you need one, you can borrow it from there. Remember that it has to be used in the lab room only, and remember, when you're done with it, please put it away. So here's our lab room in Surrey. So you've come in here and you need to borrow an oscilloscope, but where do you find them? And there's nobody around to ask. What do you do? Well, we're looking at the front of the room right now. So you look up at the front, and there in the front corner there's a gray cabinet, and beside it there's some shelves. So shelf 1, 2, 3, and if you look at the bottom of the shelf, there's the oscilloscopes. So those blue things there. So again, you find the gray cabinet in the front corner of the room, and then you go 1, 2, 3 shelves over, and the oscilloscopes are on the bottom. Remember to put them away when you're done using them. So this is your first glimpse of an oscilloscope, and the on button is up here, and there's a little warm-up screen that it has to go through before it'll allow you to take data. Another thing that's useful to know is that there are these little legs on the bottom that you can flip up, which makes it a little easier to see when it's on your desk. Makes it harder to see in this video, however, so I'm going to put those down again. And as I said, it's got a little warm-up that it needs to do, so I'll show you what that looks like when it's finished. So here it is doing its little warm-up, and now it's ready to take some data. And I'm going to show you what a signal on this looks like in just a moment, but first you need to know where to find the cables that you're going to use to patch a signal into the breadboard with, and how you put those on. Okay, so to connect your breadboard to the oscilloscope, you're going to need some special cables. Where are they? Again, this is our lab room. You're standing near the door. Turn this way and walk over here. And right here, you see some cables dangling off the side of these shelves. So you'll grab 1 or 2 of these guys as you need. So here's our lab room in Surrey, and you've come in here to use the oscilloscopes, but you need some cables. Where do you find those? So this is looking up at the front of the room, and if you come over here to the left-hand corner, where the door to the technician's office is, then you'll see some racks on the wall, and that is where the cables are located. So you can take 1 or 2 as you need to. Make sure you put them away when you're done. So how to use these cables to hook into your breadboard. So with this one, if you look at this side here, there's a little sleeve that you could pull down, and it reveals a tiny little hook made out of metal. And so you could take a short piece of wire like this, pull the sleeve down, hook the wire in there, and then it clamps that piece of wire in place. And this other end is an alligator clip, so you can just attach another little short piece of wire there, and then you can hook into your breadboard via these 2 pieces of wire. The alligator clip is the negative end, and your signal should go into the one that had the sleeve on it. By the way, the manual says that there's a ×10 setting on this that you have to set. These are newer probes, and that no longer exists, so these should be ready to use right away without any adjustments. A lot of the probes that we're using for the oscilloscope don't have a switch on them, but do check whether yours does. So this one does, for example. So just make sure that it's set to the ×10 setting. If there is no switch, then probably it's set to ×10 automatically. And either way, you do need to also make sure that the oscilloscope is set to ×10. So right now this one's set to ×1, so I need to press this button to make sure that it goes to ×10. And you access this particular menu by pressing the menu button for the channel that you're displaying. Now the screen of the oscilloscope doesn't look very interesting yet because I haven't put a signal into it. So first you need to patch a signal from the breadboard into the oscilloscope via those cables I just showed you. So you want to put this cable onto your oscilloscope. How do you do that? You're going to attach channel 1's signal onto this BNC connector, and channel 2's signal would be onto this one. We're not going to use this third one over here. So to connect the BNC connector, you take this guy and you slide it on, and then you need to twist it until it clicks, and it's a really loud click. You'll be able to feel it. To take it off, you untwist, and then you pull it off. So again, you slide this guy onto the connector, and then twist it until it clicks. Now you see a signal on the screen. Doesn't look very nice. You should read through the appendix of the lab manual to see how to set things up, but there is one button on here that's going to make your life a little bit easier. Up here there's a button called Auto Set, and if you push this, it will usually make the signal look pretty good. So it'll come up with some settings. Sometimes it doesn't work so well, it goes a little screwy and you have to fix it anyway. So as I said, you should read that appendix so you know how to set things here. But this auto set button often will do most of the work for you. So there are three sections of the oscilloscope control panel. There's a section of controls for channel 1, and a section of controls for channel 2, and then a section that has controls for the time-based setting. For channel 1, this little button here will turn channel 1 on and off. So you have to push it a few times so you can see that the signal disappears from my screen. You can also turn channel 2 on and off. So blue line, blue button, yellow line for yellow button. So I'm going to turn channel 2 off just because I don't have anything plugged into it. These knobs up here adjust the position, the vertical position on the oscilloscope screen. So I can move the whole trace up and down the screen, like so. This knob down here basically is going to stretch and squish the vertical scale for this guy. So if I adjust this, it makes the signal look taller or shorter. And I'll just point out that I'm not actually changing the signal going into the oscilloscope at all, I'm just changing the way it's being displayed. So generally speaking, you want your signal to take up as much of the screen as possible, just because you'll get more accurate measurements off it that way. You can do the same things to channel 2, of course, if you've got a signal plugged in over there. And you also want to look at these things for the time scale. So this position knob, again, just moves the signal on the screen. So I can move it back and forth with this knob and up and down with this knob. The time-based setting stretches and squishes the scale in this direction. So again, I can play with this and stretch things out or squish them up tight. And again, you probably want one complete up and down oscillation to take up as much of the screen as possible. So if you can change the voltage setting and the time-based setting on this screen, so if you can change the way your graph is displayed, it's pretty important to know what you're changing it to, right? So if I change this so that I'm on a different voltage setting, then I better know what voltage setting that actually is. So for channel 1, it's listed down here. It says 1 volt. That means that one block on the screen is 1 volt high. So right now my signal's roughly 4 blocks high. That means I've got a signal that is roughly 4 volts peak to peak. The time-based setting is listed here, so it says 250 microseconds. And again, that means that one block on the screen is 250 microseconds wide. So I can count up that my signal is roughly 5 blocks wide. That means that my period would be 5 times 250 microseconds. So we talked about these three sections of the control panel. Now I want to talk just a little bit about this last one. So this is for the trigger level. It'll be a little hard to see on the screen, but there's a little arrow here, and that's where the trigger is set on the oscilloscope. What is the trigger? It basically tells the oscilloscope at what point of this signal it should start drawing the picture on the screen. And you want it to be the same point on every cycle, otherwise it will look like this picture on the screen is moving. So what I'm going to do is I'm going to move the trigger level so that it's above the top of the signal. And you'll see how that affects things. So as soon as I get past the signal, the oscilloscope gets really confused, and suddenly it looks like my trace is moving around on the screen. All you need to have a correctly triggered scope is for this little arrow to be between the top or the bottom of the signal, and then it should be fine. So now I'm going to talk about how to use the cursors, but first let me talk about menu buttons. So there's buttons all over this control panel, and a lot of them are menu buttons. So one of them we already looked at was the menu button for channel 1. I could just push that and adjust things for channel 1. There's a lot of other buttons here that are also menus, and one of them, which will be useful to you, is for the cursors. So you press the button that says cursor, And as with all the menu buttons, what will happen is you'll get a list of things you can change here on the screen, and then you can cycle through them by pressing these unlabeled buttons right beside the screen. So I press the cursor menu button, and it says, first of all, at the top, type off. So I can change that to the first setting, which is type amplitude. Might be a little hard to see, but there's now two horizontal lines that have been added to this screen. And you've got a cursor 1 button here and a cursor 2 button here. So you can cycle and choose either one of those. So I'll choose cursor 1. And then up here at the top, you've got this multifunction dial that you can use to adjust the position of that one of those lines. So I'm moving cursor 1 up and down, so I can put it at the top of my waveform. And then I can select cursor 2, and again use the same dial to put cursor 2 right on top of the bottom of my waveform. And then on this screen, it actually tells you what the difference between those two cursor positions are. So it's telling me that I've got 3.84 volts from the peak to peak here. You can also change the type to time, and now the two horizontal lines have gone away, and I've got two vertical lines. And again, I can choose cursor 1, and then use this dial to move cursor 1 around. I'll put it at the end of my waveform, and then I'll select cursor 2, and I'll put it at the beginning of the waveform. And right here, it tells me both the period and the frequency of this waveform. So now I'm going to talk about how you get this image into your logbook. So the old-fashioned way would be that you would draw this on graph paper to scale and label your axes. Luckily, with these modern scopes, you can actually save the image on your screen to a flash drive. I will warn you, though, that the oscilloscopes can only handle data sticks up to 8 gigabytes, so your data stick needs to be 8 gigs or smaller in order for this to work. So you plug this into the USB slot on the front of the oscilloscope, and you'll see a little clock here. It needs to think about things for a while, so let it finish doing that. And when it's done, you should get your scope trace back with the menu that you had showing before. Now, before you actually take any data here, it's a good idea to set things up such that what saves onto your data stick is the most convenient format for you. So up here there's a menu button called Save Recall. So we click that, we get new options here, and at the top it says Action, and right now it says Save Image. That might seem like the right option, but there's actually a better one. What Save Image, just as is, does is it saves a folder onto your flash drive that contains the image you want. So this would work, but there is actually a better option for us. So if you push this, there's Save Setup, Save Waveform, Recall Setup, Recall Waveform, and finally Save All. So the default for Save All would be that it would save both the image and a whole bunch of data files onto your flash drive. We don't need the data files, so we can actually adjust that still. So down here below it, there's Print button. Right now it's on Prints. There's also Saves All to Files, which would save all the data there, and also Save Image to File. This is what we want. So Save All for Action, and under Print button, Save Image to File. That will save just the image onto the flash drive rather than the image plus other stuff that we don't need. So once you've got it all set up and ready, you want to make sure that the screen looks exactly the way you want it to look in the diagram you plan to paste into your logbook. So that means you probably don't want these Save Recall options from this menu up anymore. You want the cursor options back. So go ahead and push cursor again, and it gives you the cursor menu, including things like the frequency and period of this waveform. And then once it looks the way you want it to, then you can save it. The way in which you save it is there's a save button right here. So right below the knob that you twiddled to move your cursors around, there's a save button. So you push that, and it will again need to think about things. So you see a clock, and you just wait for it to time out. This actually takes a while. And once it's done, it gives you your menu back, and at this point it's safe to pop out the data stick. You don't need to unmount the drive. So next I'm going to show you a program called IrfanView, which is on all the lab computers, which you can use to then print out your graphic so it looks nice. So now I've opened up my data stick, and you can see that there are these 4 JPEG images on it. So these came from the oscilloscope, but you'll notice that the oscilloscope just named them 0, 1, 2, 3, and so on. So you better take good notes on which image is which so that you can tell after the fact which one is which. So to open these up, we're going to use a program that's on all the lab computers called IrfanView, and the icon is a bright red cartoon animal here. So you can right-click on one of these and say Open with IrfanView. And it'll open up and it looks lovely and you think, okay, I can just print this as is. Not quite. IrfanView is a very flexible program and it saves the settings that the person who used it previously had, which means it may look really insane if you just print out using whatever defaults were here, because they're not really defaults, they were set by the last person who used the program. So there's a preview up in the corner. You should take a look at that. Do you want it to be portrait or landscape? Portrait is probably better. You can print to original size, which is actually too large for the page. You can stretch it to fit the page, which is also a little bit big if you think about pasting this into your book. Custom is probably the best one, and right now this image looks really tiny because I need to adjust the values, so I'll put in 10 centimeters wide, keeping the aspect ratio the same, and I'll center it just to make sure that I know I don't have any parts of this image chopped off by the printer. And down here are the units, so you can be centimeters or inches. So if it looks okay, if it looks sensible in the preview, then you can print it out. And then you'll just be able to paste that directly into your logbook.